Hi students, today we are going to discuss the concept is inferences in first order logics. In that the first point is proportional versus first order inferences. Some simple inference rules that can be applied to sentences with quantifiers to obtain sentences without quantifiers. These rules lead naturally to the idea that first order inferences can be done by converting the knowledge base to propositional logic and using propositional inferences. Second one, inference rules for quantifiers. First one, universal quantifiers. All greedy kings are evil. So for all x of kings and greedies is equal to evils. Then it seems quite permissible to infer any of the following sentences. King John and greedy John Z implies evil John. King Richard and greedy Richard gives evil Richard. King father of John and greedy father of John is equal to evil father of John. Universal instantiations. The rule of universal instantiation says that we can infer any sentence obtained by substituting a ground theme for the variables. The subset 5 comma infinitive denote the result of applying the substitution of 5 to the sentence infinitive. Then the rule is written as for all b of infinitive divided by subset b by g of infinitive or any variable b and ground term g. For example, the three sentences given earlier are obtained with the substitutions and father of John's. Second, existential quantifiers. The formal sentence is as follows for any sentence of phi of variable b and constant symbol k then does not appear elsewhere in the knowledge base. For example, from the sentence phi of x and on head, then we can infer the sentence crown on head as long as C1 does not appear elsewhere in the knowledge base. Basically, the existential sentence says there is some object satisfying a condition and the instantiation process is just giving a name to that object. Naturally, that name must not already belongs to another object. In logic, the new name is called scalar constants. Existential instantiations is a special case of a more general purpose called scalization. Third one, reduction to propositional inferences. Once we have rules for inferring non-quantified sentences from quantified sentences, it becomes possible to reduce first order inference to propositional inferences. The first idea is that just as an existentially quantified sentence can be replaced by one instantiation, a universally quantified sentence can be replaced by the sectors of all possible instantiations. For example, suppose our knowledge base constrains just the sentences like this, and then we apply unified instantiations to the first sentence using all possible ground term substitutions from the vocabulary of the knowledge base. In this case, we obtain kings, a greedy John evil, King Richard, greedy Richard, evil Richard, and we discuss the universally quantified sentences. Now, the knowledge base is essentially propositional if we view the ground atomic sentences, King John, greedy, and so on as proposition symbols. Therefore, we can apply any of the complete propositional algorithms to obtain conclusions such as evils. This technique of propositionization can be made completely general, that is, every first order knowledge base and query can be propositionized in such a way that entailment is preserved. So these are the concepts of first order logics. Then now we are going to discuss unification. What is meant by unification? Generalized module pronouns is a lifted version of modus pronouns. It arises modus pronouns from propositional to first order logics. The key advantage of lifted inference rules over propositionalization is that they make only those substitutions which are required to allow particular inferences to proceed. So this is the first pronouns modus rule. Generalized modus pronouns rule are given in this format. Modus pronouns allow any signal A on the left hand side of the implication, while generalized modus pronoun requires a specific format for this sentence. It is generalized in the sense that it allows any number of pi. Lifted inferences rules requires finding substitutions that make different logical expressions look identical. This process is called unification and is a key component of all first order inference logics. The unifier algorithm takes two sentences and returns a unifier for them in one existence. Unifier of p comma q is equal to 5 where subset of p comma 5 comma p is equal to subset of 5 comma q. For the query knows John comma x, whose does John know. Some answers to this query can be found by finding all sentences in the knowledge base that unify with knows. Here are the results of unification with 4 different sentences that might be in the knowledge base. Unify knows John's comma x knows John comma Jan is equal to x by Jan. And the second one is unify knows John's of x knows y Bill is equal to x by Bill comma y comma John. And these are all the other unification formats. The last unification fails because x cannot take on the value of John and Elizabeth at the same time. Now remember that knows that x comma Elizabeth means everyone knows Elizabeth, so we would be able to infer that John knows Elizabeth. The problem arises only because the two sentences happen to use the same variable name x. So there is one more complication. We said that unify would return a substitution that makes the two arguments look the same, but there could be more than one such unifier. For example, unify given in this format, the first unifier gives knows as the result of unification, whereas the second gives knows this. The second result would be obtained from the first by an additional substitutions Z of John. We say that the first unifier is more general than the second because it places fewer restrictions on the values of the variables. It turns out that for every unifiable pair of expressions, there is a single most general unifier that is unique up to renaming of variables. In this case, it is in this format. So this is nothing but a simple unification algorithm. And these are nothing but the proof using criminals in the western side formats. And this is nothing but the continuation of that proofing concept. So these are all the concepts we need to discuss in unification.